Hello again and welcome. I have started a little project where I'm going to try to teach the basics of using electronic lighting, particularly the inexpensive LED addressable strips that you can get off eBay. And my approach to this is to make it as cheap as possible. The observation is if you have a lot of money, it's pretty easy to get anything done. But if you don't have a lot of money, it's a little more, you have to be creative. Um, I found this on eBay. It is an Arduino-like board. It's not exactly an Arduino, although it does work in the Arduino environment. This little chip, if you notice, there's not much on this board. It's got nothing on the bottom at all, and on the top it's got a USB interface, a voltage regulator, and the microprocessor. And that's about it. The crystal, the timing circuit's built into the chip. Pretty much all the peripherals are in there, the voltage references. It's actually a better chip than the AVR. And that's why I've gotten interested in using it, because this costs $2, less than $2. And when you get a complete processor board that costs less than $2, it's just another component. It's not anything special, and you can just use them wherever you need them. So with that in mind, I've put some resources into figuring out exactly how to make this work, and it did take some effort. It needs a special board support package, which exists, and I'll put a link to it in the comments. Also, it needs a little patch to make the LED driver work. Basically, you just have to put another line in the file telling it about this board, because this board uses timer 2 instead of timer 0. It uses timer 2 because timer 0 is dedicated to its extremely high speed pulse width modulation. So this thing's capable of I guess going to 250 kilohertz on the pulse width modulation, and a regular Arduino is lucky to do 1. So interesting, probably worth the effort. There is another minor problem. There's a little jumper here that claims to be able to go between 3 volts and 5 volts. And the chip will actually run on 3 volts or 5 volts. It doesn't care. However, the board was laid out wrong. And when you change it to 5 volts, the USB interface doesn't change. So I'll put some more detail up, but if you want to run it on 5 volts, you have to cut that trace right there. And then you have to jumper that 5 volts, not just on the pad, but also you have to jumper it over to pin 10 on this chip. I'll put some more detail up about how you do that mod. Now, they say that a computer system is capable of doing anything. That means if you're clever enough, you can make a general purpose computer do pretty much anything you can imagine. The problem is, if you're getting started, that's too many things. If you want to do a specific thing, then it's important that someone help cut away the parts you don't need and simplify things so that all you're dealing with is the parts that you'll actually need to deal with. So with that in mind, I've taken this little board and I've come up with a simplified set of cables. These cables are extremely cheap. Again, they come off eBay and they cost pennies. And this wiring gives you one drive for an LED strip, one drive for a touch button, or a push button or a switch, and 4 analog inputs, 3 of which are configured for knobs and 1 of which is configured for a microphone. And I've built a framework, software framework, that takes advantage of this particular configuration and hides most of the details from you. Now we're going to walk through this and see how we configure the development system, how we configure the board, how we start using the lights and the knobs to control things. And I had previously mentioned that this board will do 5 volts, but they didn't lay it out right. So I'll try to get a couple of better pictures, but if you look right near that little Wi-Fi like symbol, you can see I cut the trace. That trace is cut right above that little wedge. And then I added this jumper. So I'll try to put some better pictures in here. So that jumper supplies 5 volts to the USB interface interface side, so that when you jumper the chip to 5 volts, the USB interface still works. And you have to jumper the chip to 5 volts if you want to drive the strip lights, because the strip lights are 5 volt parts. So again, I've put a pigtail on there, and the pigtail terminates in one of these little 3-pin connectors, and that matches the pigtails that are on the board. And then I've also configured some pots to have these pigtails so that you can just analog voltages. And we have a microphone configured the same way with a pigtail on it so that you can have things react to music. That's always fun. So this board is not exactly an Arduino. It's close, but not exactly. To hook up the LED strip lights, you need to take the data from this pin that is labeled D out, D-O. On the back side of the board, it's actually labeled MOSI. And that's different from all the other digital pins, and that is a dedicated SPI output. So that pin can be used by the fast LED package to drive strip lights rather efficiently. The analog inputs, I'm just using the regular A0 through A1, and the button is coming in on D2. That reserves D0 and D1 for the COM port, which you might need. So these are turned down to about 1/4 brightness, and my camera really can't make sense out of them. But you can see that I'm running the standard rainbows with the $2 Arduino-like board, and it's working just fine with those few mods that I put to it. And of course, you could run any length strip you want if you can provide enough power to it. Of course, you can do anything else with it, but within the simplified electronics for art framework, this is all we need to make pretty lights and control what they do.